Okay, so let's discuss a challenging problem on telescopic product. We need to find out continuous product of 1 minus 1 by ak, where a0 is given to be 5 by 2 and ak equal to ak minus 1 square minus 2. So this kind of recursive relation is given between ak and ak minus 1 for k greater than or equal to 1, and we need to compute the continuous product from 0 to infinity. So we need to basically if we see this particular factor, it is going to be ak minus 1 divided by ak. So if we try to bring this kind of factor ak minus 1 from this recursive relation, it is going to be ak plus 1. So this is going to be ak minus 1 square minus 1, which can be very easily factorized as ak minus 1 plus 1 into ak minus 1 minus 1, right? Now to implement this particular factor ak minus 1, we can just replace k by k plus 1. So it will become ak plus 1 is equal to ak plus 1 into ak minus 1. So now if we need to concentrate upon what we need to calculate, suppose product of k equal to 0 to, suppose I am taking for the timing up to n, ak minus 1 divided by ak. So that is coming out to be continuous product of this ak minus 1 can be substituted from here. So it is going to be ak plus 1 divided by ak plus 1 into ak. K will vary from 0 to n. Now here we are getting a continuous product, and that is forming a telescopic product, because on putting k equal to 0, we are getting like a1 plus 1 by a0 into a0 plus 1 into, putting k equal to 1, we'll be getting a2 plus 1 divided by a1 into a1 plus 1, and then putting k equal to 2, we'll be getting a3 plus 1 divided by a2 into a2 plus 1. So this continuous product will continue up to last one, where we'll be putting k by n. So that is going to be an plus 1 divided by an into an plus 1. So you can see that this telescopic products, these are getting cancelled out according to the telescopic concept. So this is ultimately coming out to be an plus 1 divided by, now a0 plus 1 is already known to us, because that a0 value is given to be 5 by 2. So we can substitute that value out there. a0 plus 1 will come out to be 5 by 2 plus 1. So that is 7 by 2 into a0, a1, a2, continuous product up to an. Right? So this is what we are getting for the timing. Now we need to crack this particular product, that is a0, a1, a2 up to an. So for this, again, if we go back to that recursive formula, is this ak equal to ak minus 1 square minus 2. So we can treat it in another way, like if I square up both sides, so ak square will come out to be ak minus 1 to the power 4 minus 4 ak minus 1 square plus 4. So we are getting another relation, that is ak square minus 4 is equal to ak minus 1 square common, ak minus 1 square minus 4. So from here we are getting another relation, that is ak minus 1 square equal to ak square minus 4 divided by ak minus 1 square minus 4. So this is forming another telescopic ratio. So if we continuously put k to be 1, 2, 3, 4 in this particular relation, so we'll be getting a0 square into a1 square into a2 square, okay, like this up to, suppose we'll be finally interested with an square. So that quantity is going to be like, first we'll be putting k equal to 1, so we'll be getting a1 square minus 4 divided by a0 square minus 4, then we'll be putting k equal to 2, so we'll be getting a2 square minus 4 divided by a1 square minus 4, then a3 square minus 4 divided by a2 square minus 4, and this thing is going to continue up to an square, which is going to be an plus 1 square minus 4 divided by an square minus 4. So basically what is happening, like these factors are getting cancelled out and we are left out with an plus 1 square minus 4 divided by a0 square minus 4, and a0 is known to us, again 5 by 2. So 5 by 2 square minus 4 will going to give you a value that is 9 by 4, right? So this is the value of a0 square, a1 square, a2 square up to an square. So from here we can put that value out there in the denominator. So ultimately we will be getting, after this is going to be equal to 2 by 7 into an plus 1 plus 1 divided by this continuous product, and that continuous product is obtained from here. We are getting in the square format to be this. So by taking square root here on both sides, so we'll be getting, this is nothing but 2 by 3 into root an plus 1 square minus 4, right? So this is coming out to be 3 by 7 into an plus 1 plus 1 divided by root over an plus 1 square minus 4. Okay, so now this is the continuous product up to n, and we need to basically calculate the continuous product up to infinity. So finally we'll be taking n to be infinity. So we are looking for the limiting value of this continuous product when n is tending to infinity. Now we can see that according to the recursive formula, since a0 is taking a value that is 5 by 2, which is more than 2, okay, so a0 is more than 2, and we are getting the value of a1 as a0 square minus 2, so which is definitely going to be more than a0, and similarly a2 is nothing but a1 square minus 2, which is definitely going to be more than a1. So this is going to be an increasing sequence, that's for sure. So we can say that this particular sequence is going to be an unbounded sequence because the value will continuously increase. So we can consider that at infinity this value of an plus 1 will become very, very large. So in the very next step we can write it as, when n is tending to infinity, we can safely write it as an plus 1 in the numerator, like neglecting the effect of 1, which is very, very small, and in the denominator we can neglect the effect of 4, which will be very, very small, and the denominator is going to be root over an plus 1 square. So ultimately in the limiting sense they will be cancelled out to give us the final answer, that is 3 by 7.